Hey guys, it's me again, Mr. Ellison. I just want to invite you back and say welcome to another episode of Mr. Ellison's Math Minute. Now today what we're going to do is we're going to talk about a tricky little concept that some of my kids get kind of eerie about. And I know that even high school kids and upper middle school kids get a little leery when they look at proportions, okay? Now, when we're talking about proportions, this is how I explain in my class what a proportion is. Now, in previous lessons that I've taught, prior to proportions, I've taught my students about ratios, okay? Now, and about fractions. And how fractions are a ratio of one number over the other. For instance, 1 over 2. Now, 1 over 2, 1/2, is a ratio. It is a ratio of 1 over 2, or 1 to 2, or even 1:2. And whenever you put it into an algebraic table, in algebra, in an x and y input and output table, it would be 1, 2, and it would be an ordered pair, 1, 2. And that's still a ratio, okay? Now, I taught my kids ratios. That a ratio is it's a comparison of the top to the bottom, or sometimes a part to a whole, so to speak. And now when we're dealing with ratios, we're dealing with fractions, okay? And when we're dealing with proportions, we're dealing with two fractions. We're dealing with two equivalent forms of a fraction, and we're comparing them together. We're setting them equal to each other, okay? And this is how, when my kids hear proportions, it's like, oh, Mr. Ellison, I don't know if we're going to be able to do this. And I tell them, yes, you will. And I'm going to show you something that I don't know if y'all think this is groundbreaking, but it's really important to understand. Now let's just use an example. Two equivalent fractions. I'm going to show you how it's a proportion if you just do one thing to it. Now let's just say we have 1. Let's take that same 1/2, and we're going to make an equivalent fraction of 1/2. What's another way of saying 1/2 that's equivalent? And we're going to set it equal to, let's just say, 5/10. Okay? Now, these two fractions are ratios of one another. This is a 1 to 2 ratio, and that is a 5 to 10 ratio. All right? It's still 1/2, but it hasn't been reduced. It's equivalent. Okay? The amount hasn't changed. The size of the slices or the pieces is the only thing that's changed. Now, we've got 1/2 equals 5/10. So we have two equivalent fractions here, correct? This is what makes it a proportion. And I can do this to any one of the top or the bottom of any one of these two ratios, okay? And erase it and put a X there, a variable number, okay? Now a variable is a letter, okay? It can be A, it can be B, it could be X, it could be D or Y, okay? But this variable, it represents one of the digits in that ratio, okay? That exists, but we don't know what it is. Now, for the sake of the lesson, you guys know that it's 5/10, but I erased it and I put a variable there. That makes it a proportion. And in a proportion, there are 3 known numbers that you're given, and then one number that's unknown, okay? And I'm going to show you a little something on how to set up a proportion right now. Now, let's just say I've got a problem right here. Cindy read 10 pages in 30 minutes, okay? At this rate, how many pages will she read in 60 minutes, okay? Now, we have 3 known numbers. We have the 10 pages and the 30 minutes, okay? and we have 60 minutes. Now when you're setting up a proportion, you want to make sure the ratios on the top and bottom are equal to the ratio on the top and bottom of the other ratio, okay? Now, so what you'll do is you'll put your division bar, and you'll, for instance, this one is pages and minutes. So what you want to make sure is, when you set up your equivalent bar, your equal sign, and your two ratios or fractions, you want to make sure to line up pages with pages and minutes with minutes, okay? All right? Because if you try to mix up pages with minutes, minutes with pages, you're comparing apples to oranges. They're not the same measurements. They're not the same units of measurement, okay? Now you want to make sure, so we're going to try this. Now we've got 10 pages over 30 minutes, okay? So we're going to erase pages, and we're going to put 10 pages in 30 minutes, okay? 10 pages, 30 minutes. And that's equal to, and they're saying, at this rate, how many pages? Did they say the number of pages? No. So we're going to put a variable there. A number is there. There is a digit that represents that part of the ratio on this side, okay? There is a digit that represents that number, but we don't know what it is yet. So we're going to substitute a variable there. So how many pages can she read in 60 minutes? So we have known pages, 10, to unknown pages, pages to pages, and then 30 minutes to 60 minutes, or minutes to minutes. You want to make sure that those ratios are the same on the top and they're same on the bottom. Now, the next method we're going to do is we're going to do a method called cross multiplication, okay? Now, the way that works is we are going to start at the top with our x, and we're going to multiply across, okay? And we're going to multiply times 30. Now, from our talk of algebraic expressions, you know that 30 times x is 30x, and it's represented as 30 with an x right next to it. Now, anytime there's a number next to a variable right next to it, there's nothing in between those two, the number and the variable, that's an understood multiplication. And then what you're going to do is you're going to drop your equal sign. All right? Now, what you're going to do is you're going to cross multiply the other way. Hence, the cross. We call it cross multiplication. So we're going to multiply our 10 times our 60, okay? And it gives us 600. 600. Now, as with any algebraic expression, as with any equation in algebra, what I've started to teach my students is, when you have an equation, what you do on one side, you have to do it on the other, because it's an equation. It has to balance. There has to be a balance on both sides. It's kind of like balancing a checkbook, balancing a ledger. It has to be the same on one side as the other. Okay, you have to do the same thing. Now, in this case, when you're solving an equation, you always want to get the variable alone. It has to be by itself, okay? And in order to do that, you have to perform the opposite operation of that operation which is next to the variable. Now, the operation next to this variable is a multiplication, all right? Now, to get x by itself, we have to do the opposite of multiplication, okay? And do it on both sides. So, if we have 30 times x, we're multiplying, so we have to divide by 30, okay? We have to divide by 30. Now, when we divide a number by itself, what do we get? We get 1, okay? So it's an understood 1, and that cancels out, okay? And what are we left with all by its little lonesome? It's x, okay? So we're going to drop our x right here and our equal sign. Now remember, with an equation, we got to do the same thing on the other side. So we're going to divide by 30 over here, okay? Now, when we divide by 30, it's going to give us 20. Okay? So the value that we're going to replace x with is 20. Alright, so instead of x over 60, it's going to be 20 over 60. Okay? Or, hold on, 30. So this is 1/3, 10 over 30, and 10/30ths is the same thing as saying 20/60ths, all right? Now, if we were to reduce this, it would reduce to, you could get rid of the zeros, and it would be 2/6, which is 1/3. And the same thing here, if you were to get rid of the zeros, it's 1/3. Two equivalent fractions, two equivalent ratios, in other words, equal to each other. You get rid of one of the digits that's in one of the ratios, and we have a proportion. All right? Now, this is how you solve a proportion. If you have any questions regarding this, don't hesitate. Send me an email, okay? Or get on my blog, and my blog address is Mr. Ellison Sasic, MrEllisonSasic.blogspot.com. Let me know how this video worked for you. If it was helpful, please. I enjoy comments and responses. Like I said before, I love to streamline my videos so they're so people can understand them better and they're easier to pick up. And I know that whenever people come online to watch a video tutorial, they like it to be short. They like it to be to the point, and they like it to be helpful and easy to follow. So I do my best to make sure that I'm putting a video out there that's helpful for you. So please, if you have any concerns or any comments, please let me know. And feel free to blog me anytime. Okay, and watch my videos. I've got plenty of videos for math and for science and and social studies, and just feel free to get on there. And once again, I'd like to thank you for coming out and taking the time to look at my blog, to watch my video, and hopefully it helped you out. Have a wonderful day, and I hope you continue to be chugging that math and do it. Work hard in math, and just know that math can be fun. You have a wonderful day. I'll see you around. Bye.